Hi, I'm Lee Tushler with EE World and Design World. I'm here with Mark Gebbia from Illinois Capacitor. And I have in my hand something called a conduction-cooled capacitor. Mark, this doesn't look like a capacitor. Tell us a little bit about this form factor and what you use it for.
All right, these type of capacitors are used in induction heating mostly. They're used to form a resonant tank circuit with an inductor, where you melt metals in very quickly at a very short period of time. But they have to be cooled. That's why they're called conduction cooled. You need to run like a water cooling system over them, because they are carrying a lot of current. These units can take hundreds of amps RMS through them. Yeah, and they can be banked, and just like before, like any other cap, they can be banked or series connected to meet the capacitance and voltage ratings that you're looking for.
Do you have to do anything special to the construction of the capacitor to make it stand up to those kind of high currents?
The manufacturing of these is proprietary. You can't just make it like a standard capacitor would be made. There are special connections and all that have to be done.
So I can't just slap a heat sink on an ordinary capacitor and come up with one of these, huh?
Not that's going to be reliable.
What's the capacity range in something like that?
We go up to as high as 5 microfarads.
And how much current can it really give you?
They can take 600 to 800 amps RMS.
Wow. Well, Mark, we got 2 different form factors of capacitors here. Why don't you talk to us a little bit about what the difference is?
Okay. This particular type here was one of the original styles done. It's very heavy with metal and lots of epoxy fill. We developed a few years later this style, which is just got metal plates but has the same performance at a drastically lower cost. So it's beneficial that way. And also has more connection points as compared to like this version.
Volume-wise, they're about the same though.
Yeah, they would be about the same.
Awesome. Well, Mark, that's interesting technology. I'd say it's cool stuff, but it's a hot part. So thank you for that.
Yeah, thank you. Thank you.